Hi guys, this is Litcoder and today I'll be solving middle of the linked list, which is a linked list based problem, easy. And what we have to do is we just have to, given the head of the single linked list, we have to just return the middle node, right? So we just have to return the middle node. If there are two middle nodes, return the second middle. So, first of all, we just have to learn how these things works, how to get the middle node of the linked list. So first of all, I'll explain it with the help of paint. So assume, okay, I'll use a pencil for now. That will get the job done. So here's the first node, here is the second node, here is the third node, and here is null. This is the first case. This is the second case. First node, second node, third node, fourth node, fifth node, sixth node, seventh node, eighth node, and null. Right? Now, this is the ending. We all know. So first of all, uh, we basically find the middle of the linked list with the help of two pointers algorithms. So we just have to initialize two pointers. Like one will be the name of slow, and the other will be fast. We have to iterate through the entire list, and so basically, we can solve this in two to three approaches. This is really simple. So what we can do is we can just get the number of nodes in the linked list just by iterating it once. So we can get the number of nodes, just like for here it is 5, and 5 divided by 2, that is 2 in integer, and we just have to return the next of that, the next node of that. In this case, the number of nodes is 6, so node minus that is the number of nodes divided by 2, that is 6, divided by 2, that is 3. We just have to return the next of it. Got my point? So we can do it in O of n square approach. That is, we just have to iterate it once and count the number of nodes present in it, and we can just we can just return the next node of the middle of the node. So this is the first approach, which is not optimized, we know. So the second approach is really optimized. We can use two pointers method. So over here, there is a fast pointer and this is a slow pointer. Now, how this works, let me explain. Slow pointer, as we iterate, sometimes we go I is equals to I dot next, n is equals to n dot next, ptr is equal to ptr dot next. So slow will go like that. Slow is equal to slow dot next. I'm writing up here next, right? But in case of fast, we'll be doing fast is equals to fast dot next. So it will jump one node extra. So it will just jump on alternate nodes. If fast is over here, it will jump to here, 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 and end. Right? Now, how this works? How we'll get the middle of the linked list? First of all, we are starting start over here and fast over here. Okay, this is fast and this is start. So first of all, we'll take fast is equals to fast dot next. Fast is equals to fast dot next. Sorry, fast dot next. So fast is equals to fast dot next of next, and slow is equals to slow dot next. Slow is equals to slow dot next. So the base case will be, I mean that terminating condition will be if fast is equals to null, or fast dot next is equals to null, which is true over here. We'll stop. We'll stop, and we are at our middle of the linked list. We are at our middle of the linked list, that is slow. We just have to return this. But how we will return this? We must have a backup to this node. We can't go we can't undo this process. We need a backup. So I'll be solving this ASO. This is really simple. Let's just take one more example. So here's the second example over here. So we'll follow the same process, slow and fast. First of all, this is the first thing we'll be doing. This is the second case, and in between there will be one more case. I'll be explaining it later. So first of all, just try to understand this. Fast is equals to fast dot next of next. Okay, fast is equals to fast dot next of next, and slow is equals to slow dot next. Again, fast is equals to fast dot next, and slow is equals to slow dot next. Again, fast is equals to fast dot next of next, and slow is equals to slow dot next. Again, we'll do the same. Fast is equals to fast dot next of next, and slow is equals to next. Now, our terminating condition was if fast is equals to null, or fast dot next, the next node of fast is null, which is true for here. Fast is equals to null, and over here fast dot next is equals null. So what we're doing, we'll be terminating it, and this is the pointer, I mean the node which is pointed by slow pointer will be returning this, right? So we must have a backup to this, right? We must have a backup to this. If you are a experienced programmer, or if even if you are beginner, you must have solved swapping problems, right, with the help of a third variable. So we take int temp is equals a is equals b, and b is equals to temp, right? We'll be using the same concept over here. We'll be initializing one more mode, that is P, or backup, whatever you can rename it. I will take it as P. So in between fast. So first of all, the condition and the body of while loop will be fast is equals fast dot next of next. That's what I did in first place, right? Second will be P is equals to slow. We are taking backup. This is nothing but backup of slow, right? And we'll be incrementing or initializing slow is equals slow dot next. It's pretty simple to understand. So let's code it right now. So we'll be taking list node slow is equals head, and list node first is equals to head, and list node p is equals to new list node. This is a this is just an empty node with no data at all. So we'll start the condition, we'll start the while loop over here. So what were our conditions, can you recall? The conditions were if fast is not is equals null, we'll run the loop till fast is not equals null, and fast dot next is not equals null. It means the next of the fast pointer is not null, or next and the fast pointer is also not null. In this case fast is over here and the next of it is null, and in this case fast is at null and which is null. So we'll be terminating over here, but before that we can just iterate, right? So we'll only checking fast because it runs faster than the slow pointer, so we just have to check for it. And here fast is equals to fast dot next of next, p is equals to slow, slow is equals to slow dot next. You can also take p is equals to slow in the beginning, or whatever, like over here p is equals to slow, but it doesn't matter. But make sure you take p is equals to slow before you initialize p or increment, I mean before you initialize slow or increment slow. This is because we are taking backup of the current slow and incrementing it later or initializing it later. And here we'll be returning the next of, I mean return p dot next. So p dot next means currently we were at p was over here. I mean p was not over here. P is just a node which has no value or link of something. It's just a pointer. So before this we added this condition, right? P is equal to slow. So when it jumps or initializes, p is over here. P takes is back up. After that again, it goes, I mean, it stays over here. We just have to return this is the middle of the linked list, so we'll return p dot next. Got it? And one more time for for this case, fast, this is fast, and slow is over here. So before moving slow, we will take backup p. This is p backup. Again we'll move fast, and again we'll move slow one at a time, and we'll take slow is equals to p is equals to slow. So p is over here, and this is the backup. Again fast and slow, this is the backup. Again fast, and this is slow, and p is the backup. Now we'll return p dot next, because here it is four elements, here it is four elements, and if there are two middle nodes, return the second node. That means if there are two, these are the two. I mean, for even number of nodes, the middle linked list, the middle nodes are two. So we just have to return the second, that is p dot next. In the both cases, we just have to return p dot next. So let's run it. Let's see. It's working fine, so I'll be submitting it. Okay, we just have to check the base case. If head is equals to null, return return the head. Let's check this first. Yeah, cool. It's working fine right now, so we can just submit it. Yeah, it's 0 ms 100%. So in this case, lead code works perfectly, it's working fine, but I don't know what's happening with other test cases and problems. So yeah, anyways, thank you, thanks a lot for watching. This was the tutorial for the middle of the linked list, and I hope you guys liked it. And yeah, until then, see you, and take care. Bye.